Well, you know that old saying. Blyle, who the fuck would touch Blyle? No, I'm sorry, that's the wrong saying. That old saying, if you don't use it, you lose it. When I was growing up, my sister used to say that she felt sorry for anyone who ended up married to me. Well, the joke's on her. Son of a bitch. All right. If you don't use it, you lose it. I don't graph things by hand very often. And the last chapter, and this chapter, and the next chapter are all about graphing. Chances are you will never have to actually graph something by hand. You may, but the odds are pretty low. When was the last time someone robbed a bank and said, everyone gets to live if you can plot x cubed minus 3x? It just doesn't happen. So, why the book is dwelling so much on this, I honestly, I don't know. But there are advantages. There are things that you can learn by doing graphing. First of all, it's really good practice algebraically and stuff like that, because you're gonna end up making a whole table of points, and it's good practice. It really is. So that's not so bad. The other thing that you learn is behavior of graphs and how functions behave. This is something that can play an important role. Recently, I gave you an example where I had to estimate how many officers we're going to have to hire per year. I plotted out a function of the number of citizen-initiated service calls that we get. Then I had to translate that to our current population of officers. The translation means that I figured out the slope for calls for service, and I had the total number of employees we currently have. So what I had to do was move that slope down, move that equation down, so that we had the same kind of an increase for the number of officers that we're anticipating for the number of calls, but starting from a much, much lower point, because we don't have 10,000 officers. So I needed something that would mimic that slope, but in a different location. That's translation. And translation is one of the things we're going to talk about today. So, the book goes through several things, and I don't think this is going to be a terribly long video, but we'll find out. I have lots of masturbating to do when I get home, so I'll try and keep it short. The book talks about several types of translations, and what it talks about is how a function f of x behaves. And let's choose an example f of x. In fact, earlier today I said, you know, no one held a gun to your head and said you will die in this bank robbery unless you can plot x cubed minus 3x. So what the heck? I pulled that right out of my butt, which is why it stinks so bad. Let's use this as our example. And here's what I want to do. What we're going to do is we're going to plot this function. And the way we're going to do that is with a series of points. So I'm going to make a table. By the way, to plot it, we're going to make this equal to y, so we can actually have our standard Cartesian coordinates. we're not going to go too far. We're only going to go out 3 points. I'm going to make a table. So let's take, well, I only have 7 points lined up here. Let's go ahead and calculate the 7, shall we? Actually, I'm going to go ahead and just do 0. 0 is easy. 0 times x, if x equals 0, 0 cubed is 0. 3 times 0 is 0. This is going to be 0. 1 is pretty easy too. Let's do that, because 1 cubed is 1. Minus 3x, well, that's minus 3. 1 minus 3 will give us negative 2. Is negative 1 that simple? Negative 1 cubed. Let's see here. Remember, a negative times a negative is a positive. So 1 squared would be plus 1. But the problem is we have cubed. So we have plus 1 times another negative 1. So this is still negative 1. Minus 3 minus 1 is positive. So we have minus 1 plus 3 is positive 2. Are the rest of them that simple? Let's find out. 2 cubed is 8 minus 6. 8 minus 6 is 2, isn't it? Is that right? Yeah, that's right. 3 cubed is 27. 27 minus 8. I'm sorry, 27 minus 9. 3 times 3 is 9. 27 minus 9 is 18. So that's going to go probably right off our charts. Minus 2 is negative 8 plus 6. This is also going to be 2, isn't it? Am I doing that right? Or did I do that wrong? Negative 2. 2 cubed is 8, but it's negative. And since it's an odd power, 2 cubed becomes 8, but negative becomes negative 8. Negative 2 times negative 3 is positive 6. 8, this is 2. We're going to need, okay, that's fine. Again, negative 27 plus 9, now we have a negative 18. We kind of have a problem here, don't we? Let's plot what we know. All right, negative 2 gives us a positive 2, so we have a point here. And we have a point here of negative, so we're going to go way down here somewhere. I'm going to draw an arrow to remind myself. Negative 1 is also 2. Here's the problem. We know this is not linear. So we're going to need a point in between here to figure out just what the fudge is going on. We'll get there. We have a 0 here. By the way, you'll notice that I circle my points. That just makes it easier to see. So you put a dot there, and sometimes the dot kind of gets lost, so you circle it. Say, oh, there's a dot right in the middle of this circle. 1 gives us a value of negative 2. 2 gives us a value of positive 2. I think I might want another point there as well. And 3 is going to be way up here somewhere, way up in the cosmos. All right. What's happening between -1 and -2? I'm guessing that we're going to get an arch. So I'm guessing we're going to get something that looks like a line down, up, and down. That's my guess. Let's see if I'm right. Let's put in 2.5, -2.5. I'm getting -7.5. Something is way wrong here. Let me put you on. Well, no, you know what? I want you to see me struggle because I know it'll make you laugh. No, that's not why I want you to see me struggle. I want you to see me struggle because I want you to understand that even and I have a lot of experience with this kind of stuff, even I periodically have to stop and think. So I'm going to make you sit there and watch me struggle because I think it might be good for you. All right. That's correct. I'm going to do 1.5 real quick. All right, 1.5 is coming up to right about here. And I think I see what the problem is. I'm calculating. For some reason, my calculator is not doing what I think it's doing. So I am correct. We are going to end up with some kind of a funkadelic curve. Actually, let's do the 2.5 real quick, -2.5. Oh, I see. I'm doing 2.5, and yes, that's coming up very low. So that's where the problem is. I need 1.5. I need a point in between -1, -2. That's where the mistake is. My apologies. $1.1. Oh, this point's wrong. This point's wrong. -1, that gives us -1 here. This becomes +3, so this is actually -2. All right. All right. I'm seeing it now. If you look at the board right now, it looks like a big jumbled mess. Remember when I told you last week not to play connect the dots? Well, now we are going to play connect the dots. We're going to try and find a smooth line to connect these dots, recognizing we're going to shoot off up here somewhere. So we're going to have a curve . Kind of look like this. Is this point right? Let's see. Eight. This point's wrong, isn't it? Isn't it? -2. This is -8. This is +6. This should be -2. Shouldn't it? Ah! See, now I'm making so many mistakes, I'm starting to feel like an idiot. -2 is -8. You know, this should be -2. So this point's too high. Becomes 3. What am I doing wrong here? Come on, somebody help me out. -1 gives us a -1 here, +3 is a negative times a negative 1. -1 plus 3 is +2. That is correct. -2 gives us -8. -2 times -3 gives us a +6. -8 gives us a -2. All right. I assume that's correct. I think that's correct. I hope that's correct. All right. Now, let's talk about a couple of translations that they talk about in the book. First one is fx plus c. In the book, this is written as fx plus c. Well, let's do fx plus 1. Oops. Very important. I just made a mistake. And this is very, very important to note. This +3 is on the outside of this f of x. I just put the +1 inside the parentheses. We can't do that because we're doing that next. Inside the parentheses means we're adding 1 to x. Does not mean we're adding 1 to the function. The first translation is we're adding 1 to the function. And this is very easy to do. Actually, I'm going to erase this. I'll show you why in a moment. I'm going to switch colors here. By the way, in this table, I found another mistake in the book, and we'll talk about that in a moment. So let's switch colors. Let's do this in blue. So we have this. So, starting at -2, we go from -2 to -1. -1 becomes 3. Fuck me raw. That's why, okay. I'll tell you what I've been having a problem with here up on the board. Aside from the fact that I'm just screwing up royally. I've been looking at this. If you recall, a week or two ago we talked about powers and the number of solutions. And we said every solution to a function, if we set the function equal to 0, is where we cross the axis. And I've been looking at this, and we cross the axis 1, 2, 3, 4 times, but it's only a third power. So I've been trying to figure out in my mind as I'm talking, how in the hell do we have too many solutions? Here's why. This is positive 2, not negative 2. So this point should have been up here all along, which means our curve actually goes like this. This is the shape of the curve I was anticipating for an x cubed function. Remember I said power 3, we should have 3 solutions. The solution is where we cross the axis. Here's the solution here. Here's the solution at 0, and we have a solution somewhere around here. So we have one solution a little bit more than negative 1.5. We have another solution a little bit less than negative 1.5. So now it makes sense. All right, back on track. So negative 1 now goes up to 3. 0 goes to 1. 1 goes to negative 1. 2 goes to 3. And you should notice that we get a graph that looks just like the original, but has moved up. Missed that point, didn't I? So if we add a constant, all we do is take this graph and move it up the x-axis. If this constant was negative, we add negative 1, guess what? It would shift down. So adding a constant does not change the shape of the graph, but it does change the location along the y-axis, just the y-axis. What if we put it on the inside? Like f of x plus 1. Well now, let's do this in green. Still a little ticked off of my blood chemist for punching in my my green one. All right, what that means is now we're going to add 1 not to the function, but to the value of x. So 0 becomes 1. We already know that the value of x of 1 is negative 2. Negative 1 becomes 0. You know, that value is 1. See what I'm doing here? So negative 2, we're going to add 1 to the value of negative 2. Now, x is not negative 2, x is negative 1. If we solve this for negative 1, we're going to get the value that we've already solved for negative 1. Two plus 1 equals 3. X of 3 we solved. This is 18. 1 becomes 2, and we've solved that, and that becomes positive 2. So here's what happens. X equals negative 2, you get a value of 2, which is here. X equals negative 1, we get a value of 3, which is here. X equals 0, we get a value of 1. Equals 1, we get a value of negative 1, which is here. X equals 2, we get a value of 3, which is here. Kind of hard to see it, but if we add a constant to our variable, not to the function, but to the variable, if we add a constant to the variable, instead of shifting the graph up and down the y-axis, we shift it along the x and y-axis. Along the x-axis. A positive value of x, this point is now this point, so positive is going to move it in this direction, negative is going to move it in this direction. So we can take this whole curve and just shift it one way or the other, depending on what we want to do with it. All right. Here's the mistake. I'll shift you around here so you can see it. Really bad. In the table here, you have sketch C of f of x is greater, where C is greater than 0. In other words, we have this where we're going to multiply the function by some value greater than 0. In the next box to the right, we have sketch y is equal to some constant times f of x, and it still has C is greater than 0. This should be C less than 0. Okay? So, I'm on page 97. On the right-hand side, second box down, it says sketch y equals C f of x, comma, C greater than 0. That should be C less than 0. All right. Here's what's going to happen. I'm not even going to sketch it. If we multiply by a value greater than 0, if we multiply by 0, everything becomes 0. That's not interesting. But if we multiply this by, say, 2, our graph is going to expand. Okay? So this point, am I doing that right or am I doing that wrong? Hang on, hang on, hang on, hang on. I'm wrong. If we multiply it, we're going to expand the graph in both directions. So by adding a constant, we shifted the graph up and down. By multiplying, we're going to expand the graph. So 2 becomes 4. If we multiply by 2, for example, 2 will become 4. Negative 2 will become negative 4. So multiplying the function by a positive constant takes this same graph and expanding it out. Now the way the book is telling you to do this, it's saying, hey, this is how you can graph functions. And the way that they're doing it is by saying, okay, you graphed the function, now let's try permutating it. If we multiply by a value C less than 1, such as 1/2, if we multiply by 0.5, 2 becomes 1, negative 2 becomes negative 1, and this whole graph squishes. That's all that multiplying by a constant does. Then it starts talking about negatives. If we multiply f of x by negative 1 or any negative value, we're going to take this whole thing and flip it. So if we were to plot negative f of x, this would be a point down here, this would be a point here, this would explode up, 0 would remain 0, you would end up with a graph that looks kind of like this if we were to plot negative f of x. Now, if you think about it, negative f of x is like grabbing the x-axis and twirling it. So it's just going to go this way, okay? So we take these points, move them down here. If we multiply x by -1, we're going to flip it around the y-axis. So this will go over here. Instead of getting a curve like this, we're going to get a curve that where this high point actually is going to look very, so this particular graph is going to look very similar. But we're actually flipping it around the y-axis instead of the x-axis if we multiply x by a negative number. And of course, it doesn't have to be -1. It could be any number, and then we're going to expand it, squash it, and do all that kind of dumb stuff. So the book goes through how to use these transformations to change a plot. And it does this one last thing. Okay. The last thing that the book does is plotting by completing a square. This only works for quadratic equations. Remember, quadratic equations, the highest power in a quadratic equation is 2. The highest power is 2. And here's what the book says. And this is something I've never seen before. I find this fascinating. It says if you have a function we can factor this into this. I'm rewriting it a little bit. It just looks a little different from the way the book does it. I just don't like the way the book does it. Oops, B over A, not A over B. My apologies. All right, let's see if this is true. I just want to verify that this is really legitimate. So we have well, we can go ahead and expand this out. We're going to get x squared plus 2bx over 2a. The 2's are going to cancel, so we're going to get bx over a. I'm sorry, yes, plus b squared over 4a squared. I keep doing that. Verify this at home. You have the powers now to repeat what I've done. You might need to expand it out a little more slowly. I combined a couple of mathematical steps. Nothing wrong with that. Take your time. Do it. Make sure you're comfortable. Verify this. This is a really good exercise. I like this. If you multiply through by a now, this a and this a will cancel. This will cancel with one of these a's. We're going to end up with b squared over 4a squared. I'm sorry, it's going to cancel one of these two a's, so it's going to be b squared over 4a. This b squared over 4a cancels with this one. Look at that, they're right. I like that. That's cool. All right, I'm not going to plot this. But here are the steps that the book recommends. If you need to make a plot by hand, like everyone does, it's only the 21st century. What the hell? Everybody's having sex in the 21st century. All right. Sorry, I'm feeling, I had a Sarah dream last night. I think you all know Sarah is my ex-wife. I had a dream about her last night. It's a little heavy on my heart today, so I apologize. I'm a little more bitter than I like to be, but there it is. All right. So how do you use this to plot something by hand? So this is just another way of writing a quadratic equation. All right, so you're going to start by making a table. Start with x from whatever range you need. Negative to positive, positive to negative. Doesn't matter what order you do it in, really. We just need the value. Translate this from x to x over b plus 2a, whatever that happens to be. Remember, in a problem, you'll have a, b, and c. You'll have those values. So you can do this. Calculate this fraction, add it to the value of x. And however many values of x you have, continue that down. Take this value and square it. So now you have squared values of this. That is this function. Now here's what the book recommends. Now that you know how to do these simple transformations, plot this as a function. Once you plot this as a function, actually that's wrong. I'm wrong. This is what the book recommends. Plot f is equal to x squared as a function. F of x, f equals x squared, by the way, always a simple parabola. Plot f is equal to x squared. Next, do this transformation. I'm just still dwelling. All right, ignore that. So, do the translation where we're adding a constant, because b and a, those are constants. So even though this is ugly, this is a fraction, it's still just a number. So calculate this, add it to the value of x. And as you recall, When we did that transformation, all we did was shift the curve up and down. Nope, side to side. So if this is negative, it's going to take this and shift it this way. If this is positive, it's going to take this and shift it this way. So we end up with, let's assume that we end up with a negative value here. We're going to get the translated here. Okay. Third step. So this is step 1. This is step 2. Multiply by A. A is a constant. And as you recall, when you multiply by a constant, all you're going to do, if this constant is less than 1, you're going to expand the graph out. If this constant is greater than 1, you're going to squeeze it in. So you're going to end up with some new function here. Like this. Finally, and this really is final, because look, this looks like a series of steps. But B is a constant, A is a constant, C is a constant. So, negative B squared over 4A plus C, that's all just one constant. It's a number. That's all it is. And that number is going to do nothing but shift the graph up. If this value, if this entire value is positive, it's going to shift the graph up. This is step 4. If C is greater than negative B squared over 4A, it's going to shift it up. If it's less, it's going to shift it down. So if we assume that it's negative, we're going to get our final graph that looks like this. And that's it. That's all there is to it. So plot just a simple x squared, then shift it in blue. Then narrow or expand it in green. And finally shift it up and down in red. That's step 4. I put my red marker back. I'm not going to run and grab it. All right. That's it. This chapter, as you're doing this, you're not learning useful skills. I hate to say it, but that's the reality. You will not to say that you won't learn things. Heck, I never saw a quadratic equation written in this form before. I learned something new. So yeah, you're going to learn, and that's a good thing, always a good thing. But you're not going to ever be graphing by hand. In fact, if you want to check your homework in this particular chapter, anything you graph by hand, put it in Excel. See if you get the same graph. Easier to do this if you have graph paper rather than freehanding it the way that I'm doing it. I apologize for all of those mistakes at the beginning. But you know what? I'm human. That happens. Not everybody seems to believe that I'm human, but I am. The most important thing that you are going to be doing is learning the behavior of functions. What happens when you translate them, when you multiply and expand them or shrink them up. It's practice with how functions behave is really what you're playing with here. We actually saw well, I'm not going to worry about that. We have another chapter on graphing next week, but I think that's it for me. Once again, I apologize. I'm not playing at my usual capacity today, and sometimes that happens. We all have off days. So I hope you forgive me. Please don't cut my pay, and I will talk to you next week. Have a good one.